Hey everybody, this is Gregory from Dapp University. So in this video, I want to teach you how to become a blockchain programmer. I'll show you what you need to know in order to become a blockchain programmer, and I'll also show you the best way to learn. So before we do that, be sure to subscribe to this channel if you haven't already, and click the like button down below. That really helps these videos get found so that more people can become blockchain developers. So this video is actually going to release with an article on my website over at dappuniversity.com, and I'll put a link down to that article in the description below. And this article is going to go more in depth about everything I'm talking about in the video, and will also give you, some code examples and things like that. So check out that article over at dappuniversity.com with a link down in the description below, and also you can check out other articles about blockchain programming on my website as well. So what's the best way to learn blockchain programming? And that's what I want to start with first. So I think the best way to learn any skill is by doing the skill itself. And that might go without saying, you might know that already, but that's really like how I like to learn and how I like to teach others. But I have a really specific process for doing this, which I call a task-oriented way of learning things. And I'll explain that in detail. So you can actually see a diagram here in the article. I'll scroll this down. So really a task-oriented approach starts with a question and then sort of breaks that down into everything you need to know in order to answer that question. While most people teach you how to learn things by just giving you a bunch of conceptual knowledge up front and then teaching you some skills about how to perform based upon what you've learned, and then you can know how to do it. They teach you that way in school a lot. It's a really common learning model, but it's not my preferred learning model because I don't think it's very efficient. So let me tell you the most efficient way to learn a skill, and it's going to be the most efficient way to learn blockchain programming. This is what I'm talking about when I say a task-oriented approach. So a task-oriented approach would start with a question that you want to know the answer to. In this case, the question might be, how do I build a blockchain application? And that's going to lead to a task, and that task is going to require a skill in order to perform the task. And whenever you visit that skill, you're going to need to collect all this supporting knowledge that will enable you to perform the skill. And whenever you perform the skill, you can complete the task. And whenever you've completed the task, you've answered the question. So in this approach, you're getting all of the knowledge and the skills at the same time. And that's why it's efficient. That's why it's the most efficient way to learn any skill. And that's why it's the most efficient way to learn blockchain programming. So if you want to learn blockchain programming, you basically want to start with a very simple code example that may not make sense when you first look at it, but once you learn how to do that simple code example, and you can start to say, why does this code work? What is it doing? Then you start to answer all those kinds of questions that will give you insight into the first question you ask, which is, how do I build a blockchain application? So if you find a really simple example that will give you all the concepts that you need and also the skill that you need at the same time, you're going to learn so much faster and so much more efficiently, or with greater efficiency. So that's the best way to learn. So let me kind of show you an example of what that looks like, and I'll show you this in the article. Well, actually, before I do that though, so I admit this process can be hard if you don't know the right questions to ask, you don't know the right tasks to identify, and you don't know what skills you need to learn in the first place. I admit that can be hard. And trust me, I know it's hard because I'm a self-taught programmer. I learned blockchain development on my own. So especially when you're jumping into a new technology space like blockchain, everything is so different that sometimes it's hard to find the questions to ask. Sometimes it's hard to identify the skills because you just don't know what you don't know. But because I've been there and because I've learned all this and I've been doing programming for a very long time, I can show you the tasks that will teach you the skills that you need, and will show you all the supporting knowledge that will give you an understanding about how the blockchain works, and will also enable you to become a blockchain developer so much faster. So what task would I want to show you that will kind of jumpstart your knowledge and will give you that first little bit of insight into how the blockchain works, and also give you some skill that you can use to go ahead and start building blockchain applications? Well, I think that the sort of first skill that you should learn when you're going to become a blockchain developer is basically just how to send cryptocurrency to somebody. That's it. That's all you need to know to get started. Now let me explain. So, I'm going to show you how to do this with Ethereum. The Ethereum blockchain. I'm going to show you how to send Ether, which is the native cryptocurrency of the Ethereum blockchain, from one account to another. I'm going to do this with code, and then I'm going to explain why the code works, and then once you understand how the code works, you'll start to kind of make connections to other concepts about how Ethereum works, how blockchains work, as opposed to like a traditional web application or like a web 2.0 kind of thing. So that's exactly what I'm going to show you how to do. This code right here, don't worry if you don't understand it right away, but I want you to pay attention to what's going on here in lines 6 through 12. In fact, I'm just going to take this out. So if you look what's going on with this code, you can see this function call is called send transaction. And you can kind of guess what that means. You're going to send a transaction. You're going to send some cryptocurrency. You're going to send some Ether from one account to another. And it's got a from field. It's got a to field. It's got a value, some gas, and gas price. So some of these things might look intuitive just by looking at it. And that's good, because that means it's a good programming language. That means it's a good library. That means it's readable, and you can kind of just look at it and have a guess about what it's doing. So I want to actually break some of that down to give you insight into how Ethereum works, how the blockchain works, and that will give you a skill and some conceptual knowledge, some supporting knowledge, all at the same time. So with this code, basically what's happening is you need to understand, why does this code even work? So first of all, you'll see this first line, this web3.eth. So what is Web3? Well, I go through this in the article, but I'll explain it now. So Web3 is a library. It's a JavaScript library that allows you to talk to Ethereum. And it's sort of the main way that you want to communicate to a blockchain. And this unlocks the understanding of how does anything even talk to a blockchain in the first place? Well, it needs some sort of client, and Web3 is what's going to power these clients in order to talk to a blockchain. Kind of like a web application might talk to a server, like a web page might talk to a server. You need some sort of client that talks to a blockchain, and that's what Web3 allows you to do. And I show a little diagram here in this article. You kind of got this client that talks to a single node on a blockchain. And that gives you insight into the fact that a blockchain is a peer-to-peer network made up of a bunch of different nodes. And whenever you're using Web3 to talk to a blockchain, you're talking to a single node on behalf of the entire network. So that's what's going on here. In this first line, you're using this Web3 library to talk to a single node on the blockchain, and you're telling this node that I want to send some cryptocurrency, some Ether, from one account to another. And you do it with just a connection to a single node on the network. All right. So the next thing, and if you want to learn more about Web3, you can check out in this article. I've got a whole series on this channel and an accompanying article on my website. You can just click this link right here, and you can learn more about how to use Web3.js to build blockchain clients. All right, so The next thing is, now that you kind of understand how Web3 works, you have insight fundamentally into like how a blockchain works. Like with this code right here, you could basically have the fundamentals of a really simple blockchain application, a wallet. So if you've ever seen a wallet like MetaMask, right here, or if you've ever seen another cryptocurrency wallet like, sorry, MetaMask didn't open, but if you've ever seen another cryptocurrency wallet like Jax, where you can just send Ether or Bitcoin back and forth, like you've got the basic behavior of how that works right here. You just send some Ether from this wallet address to the other wallet address, and you could assign some user inputs and things like that. And it would need to get more advanced, right? You would need to show some transaction history. You might even want to supply like support for other cryptocurrencies like Bitcoin. But this kind of just gives you the first step into building something like that and give you insight into how they work. All right, so the next thing is accounts. So if you see this from value and this to value in this code, that's saying I want to transfer cryptocurrency from one account to another. Now, understanding accounts will teach you how the blockchain works as opposed to other web applications. So in other web applications, when you're a user, you have a username and password on a server somewhere. Like if you're going to use Gmail, you have a Gmail username and a Gmail password. And that's all stored in a database owned by Google to authenticate you as a user of that application. But if you're using a blockchain, you're a user of the network. You don't have a username and a password on a database somewhere. Basically, your account is governed by the network, by a public key and a private key. And that's what you're seeing right here, these addresses in this from field and to field. Those are representations of your public key. Now, it's not the full public key, but it's a representation of it. And that's kind of like your username. It's safe to show people. But your private key is like your password, and you don't want to show that to people. And your public key or your username is your address is generated by your private key through basically it's run through a cryptographic hashing function in order to generate that. So that's why it's safe to show it. All right, so that's how accounts work. That's how accounts work on the blockchain, and that's how we're using accounts here in this code example. All right, so the next thing to look at are accounts. Oh, sorry, not accounts, Ether. We just talked about accounts. So, that's where this value comes in. So what is Ether? Ether is the native cryptocurrency on Ethereum. And that's what we're sending back and forth here. But if you look at this value, that's a really long number. It's 1 followed by 18 zeros. And that's not actually the actual Ether value. That's what's called Wei. And Wei is, basically the smallest subdivision of Ether. It's like a really small penny to the US dollar. That's because on Ethereum, you don't really use decimal places at the system level. Like you don't really store stuff with decimal places. The computational layer doesn't deal with them. So you have to basically specify how many decimal places it can be divided by, and then just use zeros to represent that. And that's what Wei is. And that's the value you're seeing here. And this is actually just equal to 1 Ether because, Ether is 1 followed by 18 zeros of Wei. All right, so let's talk about gas. And that's a concept that kind of trips people up when they come to Ethereum and they come to like blockchain programming. So yeah, what is this gas? What is this gas price? So I've got some other videos on gas on this channel. You can check those out if you'd like to, but I'll go ahead and explain it here. So basically, whenever you are sending Ether, whenever you're like writing data to the blockchain, you have to pay. You have to pay some amount of fee. I don't know why. And that doesn't really make sense to a lot of people because they say, why would I want to use an application that I have to pay for? Right now, most of the Ethereum-based applications deal with payments. And so it's a context that makes sense to pay for transactions. But I'll explain why. So basically, reading data from the blockchain is free. You could just fetch some data and that's fine. But if you want to like send a transaction, that's actually writing to the blockchain. It's updating its state. So whenever you do this, you have to pay what's called gas. It's a gas amount to do this. So why? Because a blockchain is a peer-to-peer network of nodes that all talk to one another, right? And they basically incur some computational cost for sharing their computational resources for the network. So if I host a node, it costs me money, and I want to be incentivized financially to participate in the network. So basically, I'm going to mine transactions, and when I do that, I help write data to the blockchain, and I basically get paid for it by the person who wants to write data to the blockchain. They have to send some gas in order to do that. And that's what this gas is. You see this gas amount right here, the gas price. So what's in the gas field is actually a limit, and the gas price is actually the amount I want to pay for each unit of gas. So let me explain that. When I say gas here, that's not ether. That's not whey. This is actually representative of how many units of gas. That's just an abstract figure. So I would say it's like a car, right? 21,000 units of gas is almost like saying 21,000 liters of gas or gallons of gas. It's just a unit. And the gas price is what's listed here. So if you go to the gas station and you say, I want 10 gallons of gas or 10 liters of gas, you'll say, okay, well, how much does each gallon of gas cost or each liter of gas cost? Let's say it's $3 per gallon. Then you want 10 gallons, then you do the math. That's how much it costs per unit of gas, and that's how much total gas it's going to cost in your car. That's the dollar value. That's how you get the ether value. Basically, you just say, I want 21,000 units of gas, and I want to pay this gas price to do it. And also, I've listed 21,000 units here. That's the limit. That's the maximum amount I want to pay. But I happen to know that that's just how much it costs to send ether from one account to another. It's always 21,000 units of gas. So yeah, that gives you insight to how gas works. All right, so the next thing is, let's revisit that whole mining principle for a second, right? So, I'm showing this code example because it connects to other bigger concepts, right? There's gas, and then there's, we kind of talked about why you pay gas, but let's revisit that idea of, nodes getting paid to help run the network. And that's going to give you insight into how, proof of work works. You might have heard this. This is, based on Ethereum's consensus algorithm. So whenever a transaction is mined on Ethereum, basically all these nodes in the network, some of them opt into the mining process, and basically they solve little puzzles, and they compete to do this. And the first miner to solve the puzzle is the one who wins the transaction, and is awarded the ether that the sender paid. And whenever they do that, they submit their work, and that's the proof that the work was done, and that's what gets mined whenever the transaction is included in the network. That's what proof of work is, and that's why we have a proof of work algorithm currently on Ethereum. All right, and the last thing I want to talk about with this code example are transactions on Ethereum. So, we're talking about send a transaction. That's what's going on here. We're sending a transaction. We're just sending ether from one account to another, sending some cryptocurrency from one account to another. But let's talk about how the transactions work. So anytime I trigger a transaction, it creates a record on the blockchain. That's essentially what a transaction is. It's sort of the smallest, record that's out there. And, the blockchain is made up of transactions that are contained in bundles called blocks, which are chained together to make up the blockchain, or the public ledger, really. So let's start with an example. So I start with 10 ether. You start with 0 ether. So I send 4 ether to you, and then you send 2 ether back to me, right? Now I have 8 ether, and you have 2 ether. But there's two transactions that were created when I sent it to you and when you sent some back to me. And that's important to know because basically Ethereum uses all those transactions and sums them up to determine how much Ether I have in my account and how much Ether you have in your account. So that's how it knows that I have 8 Ether and that you have 2 Ether. Because I started with 10, I sent you 4, and you sent me 2 back. And it uses all those transactions to create the eventual result, which is our account balance. And so that's how transactions work on a very fundamental level. And transactions are written to the blockchain anytime, any write has been triggered to the blockchain. Anytime the blockchain state is changed, a transaction is created, and you get a transaction receipt, kind of like I showed you right here. So that's really it for this code example. And that kind of shows you how you can apply this learning style, this task-oriented learning style. So you take a task, the simplest task possible, that will teach you the most about the thing you're trying to learn, right? So if you want to learn to build a blockchain application, the best way to learn is by doing it. And you want to try to find smaller tasks that accomplish the most knowledge and skill so you can get both at the same time. So I hope you all liked this video. Be sure to subscribe to the channel if you haven't already. And like I said, also check out the article. I'm putting a link down in the description below. So yeah, let me know what you thought. Leave a comment below. And until next time, thanks for watching Dapp University.